Hello guys, welcome to today's new video. Today we are going to discuss about the next chapter, that is metallurgy. This is a very interesting chapter, so let us begin the video without any delay. The first thing we need to know about this chapter is definitely the chapter name, that is going to be what is exactly metallurgy. Okay, what is exactly metallurgy? So metallurgy means the process that is used for extraction. What is it used for? Extraction. Now extraction of data? No, definitely not extraction of data. Then extraction of whom? Extraction of pure metal. Extraction of pure metal. From where? From ores. Now this term, what does this mean? Metallurgy is process of extraction of pure metal from the respective ores. From the respective ores. What exactly is ore? Ore is going to be a mineral from where pure metal can be extracted at a cheaper rate and at a convenient effort. Clear? So by putting less effort and at a cheap rate, if I can extract if I can extract a pure metal from a mineral, then it is going to be an ore. Clear? That is what is an ore. Convenient effort and convenient price. These two things are very important. In the book it is written as ores are those minerals for which metals are extracted commercially at a comparatively lower cost and with minimum effort. So it's same. So you have to be a convenient effort. Too much effort you are giving, that is not going to be an ore. Okay? Clear? So this is an ore. Now what is an ore and a mineral? So ore definition I have already said. Now what is a mineral? A mineral is something that is generally extracted from the earth, naturally occurring substance. Simple. Naturally occurring substance. Now what are the substances? Compounds of metals. They are compounds of metals, but they will contain some impurities which are called gangue. Okay, not that gang what you are thinking. It is called gangue. Gangue or matrix. Okay, gangue or matrix. These are the impurities. Impurities like silica, like Fe2O3, like sand. These are all impurities. So these are all termed as gangue or matrix. Clear? So if these are also present along with the compounds, then it is said to be a mineral. And you cannot extract a pure metal from a mineral. Clear? Yes, you can extract from a mineral, but then it will become an ore. Clear? Okay. Now let us learn about some of the common naturally occurring ores of certain elements that you have in your syllabus. What are those? First one is magnesium. So the thing that you need to learn on the magnesium, ore of magnesium, is definitely you are going to learn about carnallite. Carnallite, a very specific ore of magnesium, and one is magnesite. Clear? One is carnallite, one is magnesite. That you do not have. You need to learn about carnallite. Okay, magnesite. Okay, so you are having is carnallite and you are having is magnesite. Clear? These are the two ores. Formula is not required. Okay, KCl.MgCl2.6H2 and this one is MgCO3. Clear? This one you can remember, it's MgCO3. This one is a huge one, KCl.MgCl2.6H2O. Clear? There are two ores that you need to remember under magnesium. After magnesium, we are going to learn about aluminium. Now under aluminium, you have got four, but you need to read the main ores you need to read. What is the main ore of aluminium? Bauxite. Geography also you have studied. Bauxite. Formula bauxite Al2O3.2H2. Clear? Al2O3.2H2. That is bauxite. Okay. Next, that another you will be using later on in the extraction of aluminium itself. Cryolite. Na3AlF6. Clear? Cryolite. Next you have is not fluorspar. That is feldspar. And what else you have? It's mica. Okay, mica has got a very huge big formula. Feldspar, if you can remember, you can. Mica is a huge one that I am already saying. This two you have to read, bauxite and cryolite. Okay. Next comes zinc. Next comes zinc. For zinc you need to remember zinc blend. Question might come that name an ore of zinc that has sulfide. Name a sulfide ore of zinc. Then it will be zinc blend. Clear? Another one is calamine. Okay, it is ZnCO3. One is calamine and one is zinc blend. 2 ores done of zinc. Clear? Iron I am not saying, it's very easy. Red hematite, brown hematite. Done. Many are there, you need not read all, only these 4 metals are necessary to be read. Clear? What 4 metals? Zinc, aluminium, magnesium and iron. Clear? Iron, zinc, aluminium, magnesium. 4 done. Clear? These are the first thing that you will reach from the first part of this chapter. Only this thing, nothing else is there. Okay? Now let us move on to the important part in the second part of the chapter. In the book, the second part is stages involved, that is not there in your syllabus. We will be moving on to the next part, that is extraction of aluminium. Now this part is the most important part, extraction of aluminium. Extraction of aluminium is done through 2 processes. One is called Bayard process, that is Bayard process, and one is the electrolytic reduction, that is Heroult's process. Okay. First let us learn about Bayard process. Bayard. Okay. This was given by scientist Bayard. So we are saying it as Bayard's process. Now see, in Bayard's process, we are obtaining the final product as alumina, pure alumina. But how and why? First, we have to take bauxite. Bauxite formula, as I have already told you, Al2O3.2H2. Correct? Bauxite. Along with this, we will be adding something. What we will be adding? Sodium hydroxide. Clear? We will be adding sodium hydroxide. Added sodium hydroxide. What will be the resulting product? What is going to be the resulting product? Metaluminate. Okay, this is what? Amphoteric oxide, no? Water, what is that? That doesn't matter. Is it amphoteric oxide? So amphoteric oxide reacting with a base, it will form salt plus water. What is the salt? Sodium metaluminate and water. Clear? Sodium metaluminate and water. Clear? Aluminium oxide is an amphoteric oxide. So it will form this as a result. Clear? Okay, now balance the reaction. Place 2 here, 2 here, 3 here. Balanced reaction. Balanced? Balanced. Okay, done. This is the first step, first reaction. If Bayard process comes, then you have to write the 3 reactions. Generally questions are told like explain Bayard process with the help of reaction. So you need to write the 3 reactions. First reaction is this. See the reaction I am repeating. Al2O3.2H2O plus 2NOH forms 2NaLO2 plus 3H2O. Now the question might come, what is the function of sodium hydroxide? So you have to write that bauxite dissolves in NaOH to form sodium metaluminate. Clear? Leaving behind the red mud. Leaving behind red mud. Red mud means silica, sand, clay, Fe2O3, whatever is there is left behind because it will not dissolve in this. Clear? Only this part will dissolve, bauxite. Impurities will stay back as red mud. Clear? That is removed. So first step is that we will be making this, dissolving this so that impurities get separated at the first step. Understood? This is the first step of Bayard process. Okay? Now in the second step of Bayard process, we are going to use this part, this product, we are going to use this product now. Let us see what happens exactly. So what product we have got? Sodium metaluminate, right. So let's write sodium metaluminate plus water. Written. Now say what will be formed. Sodium metaluminate plus water. Formation will be NaOH. Formation will be NaOH. Na will try to go with this. Now NaOH What else remain? Aluminium will try to go with again this. So it's AlOH whole 3. Clear? So you are getting NaOH plus AlOH whole 3. Clear? So this is the second step of Biot process reaction. In the second process, Biot process reaction, we are getting that aluminium hydroxide is being formed. Aluminium hydroxide is being formed, and this is the precipitate, right? This is definitely going to be a precipitate. Clear? So this is the second step of Biot process reaction, where sodium metaluminate is reacting with water to form sodium hydroxide and aluminium hydroxide. Clear? Okay, balance the reaction by putting a 2 over here. Done. Second step reaction complete. Last step reaction, we will be seeing that this part is giving you alumina. That is, this part is ignited at 1000 degrees Celsius, heated. That will decompose. Clear? Acha, let's third step reaction. AlOH whole 3 is heated at 1000 degrees Celsius to get Al2O3 plus H2O, 230. Clear? Understood? 230 is not a number, okay? 230 is a balancing trick. 230. 2 here, 1 here, 3. 1 to be not writing, 3 here. Done? 230. Okay. So last step we have seen that aluminium hydroxide is heated at 1000 degrees Celsius to give alumina, and that is pure alumina, please. That is pure alumina plus water. So result we have got pure alumina. But have we got aluminium yet? No. So we have not completed the process yet. This is just the first part of the process. First part of the process has got 3 sections in it. First part is over now. Biot process is over. We have another process left, that is electrolytic reduction of this particular thing. Electrolytic reduction of this particular thing. Okay? Clear? Let us move on to the next process, that is Heroult's process. Electrolytic reduction of alumina. Okay? Heroult process. Heroult process. Kind of electrolysis. Okay. Electrolyte. First thing is very important. Electrolyte. This question often is asked in the exam. State the electrolyte for Heroult's process. What we really write? You have to mention Al2O3, otherwise reaction will not proceed. So okay, fine, Al2O3 mention. What else? Only Al2O3? Wrong. 0. Nothing will be given. What will you have to write? To also write Na3, AlF6 and CaF2. Clear? This is pure alumina. This is cryolite. Okay. You can write in the name also. Generally write the name only. In bracket you give the formula. Okay. Do not write the formula in bracket name. Preferably write this and in bracket this. Clear? Okay. This one is fluorspar. Clear? This is electrolyte cryolite, this is alumina, and this is fluorspar. Clear? We are using this electrolyte to do the reaction. We are using this electrolyte to do the reaction. This is 60%, these are 20%. Okay? This is also very important. You have to mention this answer. 60% cryolite, 20% alumina, and 20% fluorspar. Clear? Cryolite is to maximum. Why? Because cryolite will reduce the fusion temperature of this particular thing. This particular reaction is supposed to have occurred at 2050 degrees Celsius, but it is not practically possible to achieve such a high temperature. In that case, the crucible only will break. It is not possible. So we wanted to reduce that. So to reduce that, we are using cryolite. So function of cryolite in Heroult's process to reduce the fusion temperature from 2050 degrees Celsius to 950 degrees Celsius. Okay. Now we will say, what is this being used for? This also has a use. This is acting as a solvent. Clear? And also increasing the electrical conductivity of this electrolyte. Okay. Understood? 2 reasons done. Powdered coke is also another thing that we are spreading over this electrolyte. Powdered coke. That is to reduce the heat loss by radiation and to prevent the burning of anode. Two things we are using for powder coke. Clear? All these are need to remember. So this is the electrolyte that will be using for all Heroult's process. Okay. Next, dissociation reaction. What will be the dissociation reaction? Al2O3. If Al2O3 will dissociate, then it will dissociate into Al3 positive. How many are there? 2. So 2 plus oxygen. How many? 3. So you understand oxygen each is 2 minus. How many are there? 3. So 3 2 minus. Clear? 2 into 3, 6 plus 6 minus. Done. Net negative. Net neutral. Clear? Net neutral. We want a net neutral, so this is net neutral. Clear? Okay. Done. Next, Na3 AlF6 dissociated to form Na positive 3 times, aluminium 1 time, fluorine 6 times. Clear? Any problem in dissociation reaction? CaF2. So Ca2 plus 2F minus. Now say, who will go at the cathode? Who is deemed to go to the cathode? See the reaction and tell who can go to the cathode. We are concerned with which element? Aluminium. Aluminium we are concerned with. Another element we are concerned with. And no, it cannot go. See, calcium is located below. Sodium is also located below. Aluminium is located below. Clear? Sodium is top. Then comes calcium. Then is aluminium. So who will go? Aluminium will go. Clear? So aluminium is going. So in the cathode we will see aluminium there. Now who will go to the anode is very much big question. Who will go to the anode? First let us write the cathode reaction. Then we will be bordered with anode. Okay? How much current is needed? How much things are needed that we are least bordered with. Okay? That we are least bordered with. Clear? Okay. Understood this? Achha. First let us do the cathode, then we will be seeing the anode. Clear? Just understand that here fluorine is there and here oxygen is there. Who is this? Oxygen. So oxygen will go to the anode because fluorine will not go. Electrochemical series of anions. Okay. First let us see what will happen in the cathode. So cathode, aluminium will go. So as I have already told before that cathode is for cations. So if cations are going to the cathode, cathode is a negative charged. Clear? So cations going. So Al3 positive, sign positive, here also positive. How many positive? 3 electrons. Forms aluminium metal. Now in your book might be there is 4th place, 12th place, 4th place. Remove that 4, no problem. Okay? Because you can take common from all. So this reaction is perfectly okay. Now in anode reaction. So as I have already told that oxygen will go to anode. So if oxygen goes to anode, what will happen? It will react with the electrode. Electrode is graphite. Electrode is graphite rods, right? We have suspended graphite rods in Heroult process. Generally, the setup that we do, it has got graphite rods. Okay, so it will react with the graphite rods. What will happen? Graphite is carbon. Allotrope of carbon is graphite, right? So it will react with carbon to form first step monoxide. Second step dioxide. Clear? Second step dioxide. But these are not the things I am going to write in the primary step. These are secondary reactions. What is the primary reaction? What is the primary reaction? These are the secondary reactions. These are the secondary reactions. But what is the primary reaction? If it is asked, write the anode reaction and 1 marks is given, if this will not give you the marks. What we have to write? Oxygen, this is oxygen, minus 2 electrons gets atomic oxygen. 2 atomic oxygen combines to form dioxygen. Now this dioxygen will combine with the graphite rod to form carbon monoxide, then carbon dioxide. That is the complete anode reaction. Clear? So a reasoning can come, graphite rods generally diminished in size, anode diminished in size. Why? Because it gets oxidized. Add oxygen. Clear? Adding oxygen, simple oxidation. Clear? So it gets oxidized due to oxygen that is evolved at the anode. So it needs to be periodically replaced. Okay? This is the Heroult's process. This is the Heroult's process that you need to read. Now from here we get 99.8% pure aluminium. We have got another process, that is Hoope's electrolytic process or electro-refining of aluminium, that is not there in your syllabus. Okay, so you need to see these reactions very carefully. Questions are often asked. Okay, now let us move on to the last part, that is alloy. What is an alloy? First of all, alloy is basically a homogeneous mixture. It cannot be a heterogeneous mixture. Okay, alloy cannot be heterogeneous mixture. So alloy is an homogeneous mixture. Homogeneous, right? Homogeneous. Alloy is homogeneous mixture of metals, two or more metals with certain non-metallic elements. Certain non-metallic elements, or it can be other metals also, that is not a problem. Clear? So it can be with certain other non-metallic elements, or it can be with some other metal, that is not the problem. Clear? Clear? So it can be with certain other non-metallic element or certain other non-metal element. Clear? Okay. So this is the definition of an alloy. Now they will get lot of things there. Fusible alloy, amalgam, these are not there in the syllabus. Okay. What is there in the syllabus is the type of alloys that we need to read. Okay. For example, we have aluminium duralumin. Aluminium duralumin. Components of duralumin, that you need to memorize in order. Component of duralumin in order. Aluminium has got one alloy, duralumin, and one is duralumin, and one is magnesium. Clear? One is magnesium and one is duralumin. Two. Clear? Duralumin has got components aluminium, components copper, components magnesium, and component manganese. So if you cannot remember the percentage, you can remember the order in proper order. Clear? So aluminium, copper, magnesium, zinc, that has to be in the proper order. Clear? Magnesium, if you see, duralumin has this, magnesium, this will not be there and this will not be there. Rest whatever is there will be there. This part will not be there, this part will not be there, this and this will be there. Aluminium and magnesium, that is magnesium. Clear? Okay, now this particular thing, duralumin, is used in making aircraft bodies because it will light. Clear? Light tools, this. Pressure cooker, this. Clear? Aircraft entire thing is made up of magnesium. Clear? Okay. It is strong, light strong. Clear? Metal mirrors, light tool, beam balance, household appliance, all are made up of magnesium. Clear? Next, iron. You have all heard about stainless steel, right? Resistant to corrosion, that is stainless steel. Stainless steel has iron, chromium, nickel, carbon. It is made up in your ornamental pieces, in your utensils, everywhere you see stainless steel. Clear? Manganese steel, tungsten steel, not there. Next comes brass. See, brass is copper, zinc, and you add in between tin, it becomes bronze. Clear? Bronze. This is brass. If you add one tin in between, it will be bronze. Clear? So where will you see find brass? Container, musical instrument, electrical goods, screw, decorative hardware, and bronze. Everyone has a bronze medal, I am sure. Bronze medal, statues, bronze statue of the dancing girl is there, right? Then utensil also bronze are there, right? German silver is not there in syllabus right now. Lead is solder. Lead is solder. Solder and another one is type metal is not there. Solder has lead and tin. Clear? Lead and tin. After tin you add antimony, it will become type metal, is not there. Clear? So you have lead and tin, that is solder. Lead and tin, solder. Where will you find solder? Solder is for soldering purpose. and fuse. You use a fuse, right? You have seen a fuse. What is a fuse? Whenever excess current will flow or current will exceed the safe limit, the fuse will melt, fuse wire will melt and disrupt the current flow. That is a fuse. So this fuse has to be made of something which will melt at a temperature, right? So it has got a MP low, melting point low. Suppose you are using a fuse, understand, fuse you are using. So I am going to little bit physics, but okay. You are using a fuse. Let's say you are using a fuse. This is a circuit. So this is not going to be like this. This is going to be. I am just drawing a basic circuit. Okay. This is not going to be this. But a housing system is definitely not this. Okay. So you are using a fuse. Current is flowing from here to here to here to here. Okay. Suppose safe limit for current. Safe limit for current is let's take 30 ampere. Clear. Now it is flowing 30 ampere, no problem, current will flow and will flow, current will flow. Clear? This fuse has got a melting point of around 180 degrees Celsius. Clear? Melting point of around 180 degrees Celsius. Solder generally has 180 degrees Celsius. Clear? So if this 30 degree exceeds to 40 ampere, this temperature will increase, right? Heating effect of current. Fuse works on the principle of heating effect of current. I am talking about so much physics. Anyways, so this will, current will, so heating will start. So as a result, what will happen? This particular wire will get heated up. So as it reaches this temperature, what will happen? This will melt. So this wire will be this. No, this wire will be now melting. So this current will be disrupted over here. So current will not flow over here. As a result, that particular part will not work. Clear? This is the thing of fuse. Excessive heat might cause fires, might cause sparks, anything it can cause. So in order to prevent that, we use a fuse. Clear? So fuse has got low melting point. That is why we are using solder for soldering purpose. Clear? Okay. Okay. So this is all from metallurgy that you need to read. Metallurgy was a very small one since the main part B is not the inner syllabus. Okay, so that was all from the metallurgy part. In the next video, we'll be beginning with the study of compounds. 4 study of compounds are there, and finally we'll go to organic. Okay, so see you all in the next video. Hope you have enjoyed watching the video.